Hello. So here we've got questions on logarithms, but with a twist. You asked for it, guys. You asked for it. Simultaneous equations. So let's go into it. We've got a equals 3b, and we've got log to the base 3 of a plus log to the base 3 of b is equal to 2. So what I'm going to do is I'm actually going to replace this a over here with 3b. So I can rewrite this as log to the base 3 of 3b plus log to the base 3 of b, and that's equal to 2. Now, from here, there are many ways in which I can go about doing this, but what I'm going to do is I'm just going to combine the logs. It requires the least amount of thinking. So, log to the base 3 of 3b multiplied by b, so that gives us 3b squared. Using our addition law, 3b times b is 3b squared, is equal to 2. Then, from here, using the inverse of log to the base 3, which is 3 to the power of something, I can write this as 3b squared is equal to 3 to the power of this number here, 2. Okay? And then I have 3b squared is equal to 9. So b squared is equal to 3, which means that b is equal to the square root of 3. Let's also write b is equal to minus the square root of 3. But I just want to show us that if I were to use the square root minus the square root of 3, in here, that would become log to the base 3 of minus the square root of 3. But logs cannot take negative numbers. Okay, so we're actually going to cross this one out because logs can only take positive numbers. That's when we're talking about real numbers, okay? For real outputs. For real outputs. And by that, I mean numbers that are whole numbers, integers, fractions, even your irrational numbers, just not square roots of negative numbers and things like that. That's what I mean by real numbers. So in actual fact, our only solution is b is equal to root 3. Therefore, a is going to be 3 times root 3. And this is our solution set for this question. There we go, guys. Take care.